Okay, so this is the second part of the notes for implicit differentiation, day 3. I'm working the first problem on the back on page 6. So this one is asking us to differentiate the equation x cubed plus 3xy squared equals 1. And so hopefully right away you notice that we are looking at the product of x and y squared, so we're going to have to use the product rule. And just like on the last example, they're asking us to differentiate with respect to t. And again, we're going to express dy dt in terms of dx dt. So again, I'm going to start by taking the derivative of both sides of this equation with respect to t. So my first term is x cubed. If I differentiate something to the power of 3, I'm going to get 3 times that stuff to the power of 2 times the derivative of that stuff, this time with respect to t. For my next term, I have 3xy squared. And that 3, you could kind of view that two different ways. You could view it as a constant multiple and pull it out, or you could just kind of group it with the first term. So I'm going to kind of look at this as 3 times x times y squared whenever I do my product rule. So whenever I do apply the product rule, I'm going to have my first piece, 3x, times the derivative of the second piece with respect to t, which will be 2y times the derivative of y with respect to t. Then I'm going to have my second piece, I'm going to add my second piece, y squared, times the derivative of the first piece, which will be 3 times the derivative of x with respect to t this time. So that takes care of my product rule. That's equal to the derivative of 1 with respect to t, which is 0. So now, again, I want to, and I'm just going to clean this up real quick. I want to isolate my dx dt's on one side and my dy dt's on the other. So I have 3x squared dy of dx. dx dt. Plus 3 times 2 is going to give me 6 times x times y times dy dt. Plus 3 times y squared times dx dt equals 0. And I want dy dt on one side, so everything with the dx dt I'm going to move to the other side. So I'm going to subtract this 3x squared dx dt. I'm also going to subtract this 3y squared dx dt, and that's going to leave me with 6xy dy dt equals squared dx. Dy dt, notice I have 2 dx dt's. I'm going to go ahead and factor that dx dt out. So I have everything in terms of something times dx dt. So when I do that, I have 6 times x times y times dy dt equals negative 3x squared minus 3y squared times dx dt. So I'm just pulling that dx dt, factoring it out of both terms. So now to finish solving for dy dt, in terms of dx dt, I'm going to divide everything by 6xy. So I get that dy dt is equal to negative 3x squared minus 3y squared divided by 6xy times dx dt. I could even go ahead and reduce everything here by a power of 3. So I have negative x squared minus y squared divided by 2xy times dx dt. Okay, and let's go ahead and take a look at that last example. Again, we want us to differentiate with respect to t, and again, we want us to find y dt in terms of this time we're looking at the equation y to the fourth plus 2xy plus x squared equals 0. So again, hopefully you're seeing this and you're seeing this product of x and y, and you recognize that you're going to have to apply product rule in order to take the derivative of this term with respect to t. So for my first piece, I have y to the fourth. The derivative of y to the fourth with respect to t will be 4y to the third times the derivative of y with respect to t. Plus, and again, I'm going to approach this to kind of the same way I did in the last problem. I could pull it out of everything and just multiply it times the derivative of x times y, but I'm going to go ahead and group it with my 2x. So I'm going to look at this as 2x times y. So when I take the derivative using the product rule, I have my first part, 2x, times the derivative of my second part with respect to t will be dy dt. Plus my second part, y, times the derivative of the first part with respect to t will be 2 times dx dt. Oh, not equals, because I still have this one more term. So plus, that takes care of the product rule for the middle term, plus the derivative of x squared with respect to t will be 2 times x times the derivative of x with respect to t, and that's going to be equal to 0. So I'm going to take my dy dt's, move them to one side, my dx dt's, and move them to the other. So dy on the left side, if it has a dx dt, we'll go ahead and subtract it to move it to the other side. So when I do that, my first term here is 4y cubed dy dt plus, and then I have 2x dy dt. If I subtract this part, I've got 2, so minus 2 times y times dx dt. And if I subtract this part, I'll have minus 2 times x times dx dt. Now notice that on the left side, I could factor out a factor of dy dt. So let's go ahead and do that. Dy dt. So I'd leave me with 4y cubed plus 2x. And on this side, I have a factor of dx dt that I can factor out. So I'm going to go ahead and do that. If I pull that out, I've got 2y minus 2x times dx dt. And so then to finish solving for dy dt, I would need to go ahead and divide both sides by 4y cubed plus 2x. Since everything here has a factor of 2, we can reduce it. So we get that dy dt is equal to negative y, if I divide that by 2, minus x, if I divide that by 2, over 2y cubed, if I divide that term by 2, plus x, if I divide that term by 2. And then it's still multiplied by that dx dt.